Okay, hello. I'm going to be talking about the first half of our quarter, and David's going to pick up and talk about the second half in a bit. But we think that this is a pretty good split that makes sense because I think you could kind of split our quarter into two. The beginning of our quarter, I think we maybe felt like the progress was slower than it had been in our first quarter in DTR. And I think we were going through some growing pains, if you will, and kind of what we felt like was like this slow part of progress or a bunch of big blockers was actually the biggest blocker was just that we didn't have the research methods or understandings yet to really move forward in our project. And so those blockers in the beginning of our quarter, I think, were really, really necessary for us to end up making the progress that we did by the end of this quarter. Um, so what that really came from was, I think, a lack of an understanding of really what the specific problem space that we wanted to tackle was in our project in order to understand kind of the larger mechanisms of how we can make this project work. So to get more specific is that by the end of our winter quarter, we had decided that we wanted to test system models when we got back for spring quarter. So we wrote up a study design at the very end of winter quarter that we were going to just jump into the beginning of this quarter. But it was for system models, but it was just testing feedback systems. So ways to tell users when they had gotten off track when programming. And looking back on that now, we didn't even have a regular testing suite that was extensible. We weren't even sure if the testing suite that we were working with worked. And we were only working on the efficacy of individual exercises instead of them as like a group of exercises that could lead a user through those series of exercises to end up being able to recreate the whole thing. So when we went to talk in SIG about testing those feedback systems, we immediately got a lot of feedback that's kind of reiterated what I just said, that it doesn't make sense to start testing feedback systems when you don't even know what your base system is going to look like that you want to get feedback on. So in the next sprint we kind of changed our plan for testing, and we wanted to focus a little bit differently and try and find out a different way to test our system model. And we thought that maybe a good way to do that was to switch from our XKCD example, which we thought was maybe too easy, to a harder code base. I think the problem was that we didn't really have a good enough understanding of XKCD at the time to really understand all the nuances of the program. But so we tried Dark Sky, MacBook Pro, Tumblr, and I think one or two others. But there we were using Isopleth ineffectively, and I don't think that we were getting kind of the important parts of any of those code bases out of it. Especially, we weren't realizing that XKCD had the important things that we needed in order to run good tests on and also be able to kind of maintain the scope of what we were working on, because the rest of those code bases got really big and made it really hard for us to kind of isolate what we were working toward. So we spent a lot of time doing that. And then we also spent a lot of time digging into, not a lot, but some time digging into Rail technologies, so like existing SIG technologies, because we assumed that when we actually started building out the system model that it had to be something technical. Again, kind of showing that we didn't really understand what a system model could or should look like depending on the stage of our project. So by the time we got to sprint 2, after kind of futzing with the study design back and forth and really struggling to figure out like what was the thing that we needed to test, we kind of landed on we needed to test macro structures. And that means, right, the components of a program, the large components of a program that when put together actually create the structure of the program itself, and as opposed to microstructures, we call them, which is like the individual lines that make up the program. So we thought that that was important because it's this idea of, can a user wrap their head around how a program's constructed, not just line by line, but how the pieces are working with one another to make the behaviors happen, which is important in a language like JavaScript, where a bunch of things are happening at once and it's not the sequential line by line happening. So we created a study for that one, and this was the first study that we actually ended up running after all this time of kind of futzing with studies, or they ended up like running in a real way instead of just doing small little tests on. And what it was basically a series of 3 exercises that if I had more time I'd get into, but I'll get into it really fast. We did an input-output. So we gave users XKCD functions all broken up into individual functions. So they didn't get the whole code base. They just got individual functions. And then we asked them for each function to identify the input and the output um, of that function and the other functions that it was reliant on, so functions that were called within it. And then the next thing that we had them do is create a directed graph where they connected the functions that were being called to the functions that were calling them to create this kind of like web of functions so they could understand how these different functions were all working with one another. And then finally, after they went through all of that and identified which functions were changing the DOM and how and where the DOM was actually changing or what visual aspects were changing based on that function. Then we took all of that away. We gave them only the name. We gave users only the names of the functions, and then we asked them to recreate the macro structure, which basically just meant writing pseudocode for them. And it wasn't a perfect test, but what we really focused on was measurable outcomes. So whereas before we didn't really know what we wanted to get out of studies, which is why we kept on writing studies that weren't really focused on what we wanted, this time we actually ended up writing a rubric before we even started, which really helped us focus in on these are the things that we want to be testing for. And so this is how we're going to design our study in order to make sure that we're getting at those points. And that was really important for our progress because it was at that point where we, one, understood what a system model could be after having long talks in SIG about that, and two, understood how we could best get towards that goal of what we wanted our system model to look like or what we need to understand in order to start modeling a system model by creating those measurable outcomes. And that was the first half of our quarter. We finally kind of like hit a stride at the very end of that.
Great. So I'll be talking a bit about the second half of our quarter, specifically going from sprint 3 and then onward. So by the time we got to sprint 3, we were kind of at a point where we were wondering, okay, we have this idea of, maybe a user would be able to piece together this macro structure understanding if they had some solid understanding of the inputs, the outputs, the reliant functions, and the global variables that different functions touch at different pieces of that interaction. So our hypothesis heading into our status update was, okay, well, maybe if we give a user a list of the inputs and outputs, a list of the functions it calls, and all that stuff, which we're denoting as being a code signature, that a user will have then enough information to reason about the function's importance in the larger context, or it will be able to understand, okay, I understand what drag's purpose is in order to achieve this ulterior or this overarching, outcome that the program is designed to, carry out. So by the time we got to our status update exercise, we asked them to generate code signatures, those same code signatures for drag, but we had already given them one code signature for a function called update. Now, update is something that is called from within drag, and we were hoping that by giving them the information and by giving them the information in this format, that we would be able to test whether or not this format of the code signature would be enough or all that a user needed to understand another piece of code's context or importance or significance to that larger overarching macro structure. So we chose for them to analyze drag, which was, and drag specifically is the function that is most directly attached to the event listener on the interaction that they have. So users actually ended up showing that they had, they kind of had to be thoughtful with their responses. And they were very thoughtful with their responses, and they correctly started to identify the different ins and outs of drag, while also beginning to speculate about the significance of the global variables that are referenced or touched in this specific function. And by doing that, we figure that they're already starting to reason about, okay, well, what is scroll delta really paying attention to? Why does it matter? And when does it matter? And by starting to ask yourself those questions, you really start to, dissect what the program is really kind of aimed to do or designed to do. By the end of the exercise, we found that people were actually having, they did a pretty good job of being able to give some kind of explanation as to, some type of explanation to the question from start to finish what happens in the code when a user interacts with the comic shown on XKCD, be specific as possible. So many people were able to correctly identify that drag is waiting on drag events, is waiting for drag events on a container and generating additional pieces of that tile via a lazy loading technique if it is detecting a scroll that is large enough or if that is triggered. Still, though, after looking at some of the feedback, we realized, okay, some people are really kind of giving us very detailed, very specific explanations of that macro structure. And others, while they may have some idea of what's going on, they didn't necessarily say what we needed them to say to be able to confidently assert, like, okay, this person understands what's going on. This person has an accurate and clear understanding of the macro structure itself. Um, so with that, we hopped into sprint 4, kind of more interested in defining clear outcomes, and then also trying to figure out, okay, for the people that didn't understand that this was a lazy loading technique, how can we usher them into a space where they're able to recognize that, or they're able to kind of see or detect that maybe additional pieces or images are being downloaded whenever that drag happens. We did this by including we did this by having people also reference the network tab of Google Chrome's inspector tools. And by seeing the network tab as soon as the page loads, and by watching that network tab as you interact with that comic, people were able to see, okay, well, as soon as I drag to the right, this next square image of this comic is uploaded or downloaded to my computer. Um, and people began to see that, okay, the more I drag, the more files that end up getting downloaded. And eventually people started to realize, okay, this entire comic is actually just a lot of really small, or I guess really big images that are stitched together to create this larger comic. But we don't want to load all of those at first. We only want to load some of them. And we can load additional tiles, I guess, as the user actually interacts with the comic itself. So by the time we got to that level of understanding and the feedback that we got from our users, the quarter was pretty much over. But we figured that was actually a pretty good place to begin winding down. So we spent a little bit of time wondering about kind of what parts of this we can actually automatically recreate, or systematically kind of recreate, or what parts of the system we will actually be able to support building out. We found that a good number of it is actually going to be pretty possible, but one thing we're still kind of grappling with is how it is that we're going to validate or ensure or tell the user that their answers were correct when it gets to the question of, okay, now what is this function doing in a larger context, since that's not the kind of response or the kind of question for which we can automatically verify or automatically determine whether or not their answer was right or wrong. So we're still kind of dealing with that question, but we left off in sprint 4 with some of those questions still unanswered, and went into sprint 5, still kind of thinking about system modeling, but also kind of definitely, I guess, tending to in the quarter deliverables, and also kind of making sure that we documented all the progress that we had to ensure that we're ready to go in the fall. So that was our quarter. It was definitely very insightful to kind of go from a place where we were still kind of speculating how we were going to test this to now being at a place where we're saying, okay, we have a pretty good way of making sure that an intermediate developer can understand how XKCD's comic interaction is working. So excited to figure out how we can start to replicate this on other sites going forward, and